All right, who will win the race? Kevin and Nina are competing in a bike race when Kevin is 90 miles into the race. He is in first place. Nina's in second place and is 15 miles behind old Kevin. From this point, Kevin continues the race at a constant rate, 25 miles per hour. And Nina continues the race at a constant rate of 30 miles per hour. When will Nina catch Kevin? Solve this problem. All right. So the first thing we need to do is draw a picture of Kevin. So there's a bicycle right there with Kevin. Kevin's on a bicycle. I don't know how to draw a bicycle, you guys. And then we got Nina, who's also on a bicycle. And maybe it's one of those ones that leans like this. I don't know. Maybe it's one of those tricycle ones, though. Right? The ones that have two wheels like this. And then you sit back. And then you pedal. Those look really fun. Anyways, I prefer motorcycle myself. But in any case, those are the pictures that I have. If it doesn't look exactly the same, you'll lose points. That's not true. I really don't know why they wanted a picture there, because the graph will be a good enough picture for us, okay? So on this graph, let's go and graph these. We'll start with 0. That's the time that it gives us where Kevin is 90 miles. Did I say 90? What the heck was that? Kevin is 90 miles into the race. So we're not worried about going 90 miles because we don't know what happened in between 0 and 90 miles. But from 90 miles we can determine. So Kevin, we will put him in purple, his line. And we can see that he's, well, I guess we could start at 90 right there, right? So this is the distance, the why. And I've got that point right there at 90. So we start him at 90 miles per hour. And then every hour he's going to go 25 miles, right? Because he's going at 25 miles per hour. This is Kevin. So he's 90 miles into it at 25 mile per hour. So after 1 hour, how far away would he be in distance? Well, we'd take 90 and add 25, which would be 115, right? And then that's how far he would be after that first hour. Well, if we add another hour, so this would be 2 hours now, how far is he now? Well, we're just going to tag on another 25 miles from this, where he's at 115. So we'll go up 10, 25, bam, I get 140 in the 2 hours. And in 3 hours, another 25, so that's a 65 right here. And then another 25 should put us at 190, right? So Kevin has a line that should look something like these. I'm just connecting the points, you guys. Something like this. Okay? So in this problem, for Kevin, what is the slope of Kevin's line? 25. And it would represent 25 miles per hour. What about his y-intercept? What does that represent?
He started at 90 miles.
Started at 90 miles, okay? So we have a y-intercept. We got sloppage, which means that we can graph a line. Now, of course, we may not expect someone to have a linear relationship while biking, especially after 90 miles. But it's convenient for us because then it's not curvy. All right. Well, right here, I've got Nina. I'm going to put her line in red. And we know that she's biking at 30 miles per hour. So Nina's at 30 miles per hour. But if she's 15 miles behind Kevin when he's gone 90 miles, how far has she gone? 75, right? So I'm going to put a point at our y-intercept, which would be 75, about right there. And remember, she's at 30 miles per hour. All right, so we do have that y-intercept at there, 0.75. Now she's going 30 miles every 1 hour, so starting from 75, after 1 hour, we're going to increase hers by another 30 miles. which would be
105.
105, right? Now what do you notice just happened between Kevin's point at 0 hours and Kevin's point at 1 hours with
Then
Nina's?
now closer.
Now they're closer by how much specifically?
5.
5. Is that what we would expect?
Yeah.
Yeah, sure, because Nina is going 5 miles faster every 1 hour. So, at 105, she's going to go another 30 miles the next hour, so that would be 135, right?
It's gonna end up.
Now again, it's getting very, very close. So at 135, if she goes another hour, then she would be at 165. And we can see the point of intersection right there, right? Now if she goes another hour, let me get this point right again. So now we just need to connect these points to make ourselves a good old-fashioned line. And there we go. So these two lines, we can see they get closer, closer until they meet. And then like, that Shakespeare ending, they drift apart forever. Okay? So Nina now is after, well, let me ask you guys this. At what point is Nina leading or in front of Kevin?
At the 3 hour mark. Or in front of her?
Yeah, in front.
Well, it could be like 3.001.
Yeah, very good. As soon as you get past 3 hours, then Nina is now in the lead. Can Kevin ever regain the lead?
No.
Not at that pace. He will have to speed up, right? All right, very good.
Nope. He can never regain the lead. Because
It's unfortunate for Kevin, but yes, math has doomed his life. But that's what math is, mental abuse to humans. So,
I
We're good
so
there.
agree.
right, yeah, we're good. So, we all understand that.
nobody's.
All right. Well, sorry about that. Okay, so it wants us to make a table as well. So, all right. So we are gonna make it. Of course, you don't want to make it, but let's look at this in time for 0, 1, 2, 3, 4 hours. Did we get 5 hours on that table? I think what they want us to do is to extend the table. So I would make this time right here in hours, of course. This can be Kevin, still, good old Kev,
Oh no, for Kevin, no, we. Yeah. Okay.
and the next one can be old Nina. I can't fit the A in though, so Nin, which I think is short for ninja. But in any case, how far has Kevin gone at 0 hours? 90, right? How about 1 hours? So we just add 25 to that, right? 115. Then another 25 at 25 miles.
140?
Yeah, 140, right?
Yeah.
Am I doing that right? Yeah, that should be good. And then another 25. That's when they met at 165. And then another 25.
They start drifting apart.
190. Yep, now they're drifting apart.
It hurts.
So let's continue this. If they went 5, 6, 7, 8, and 9 hours,
Although we probably swore.
Kevin 5 hours. What?
What?
Now we got 215, then 240, then 265, then 290, and then 315. Bam. So there's Kevin's table. Okay. Well, this one's still full of tragedy. Thank you for that anyways. Nina, how far did Nina travel? Had Nina traveled after 0 hours? Now on the graph we had shown that she was at 75 miles, right?
Oh.
Now remember, she's going 30 miles every 1 hour, so after the next hour she would be at 105. And of course we're seeing how close they're getting to each other as every hour passes now, just numerically. So add another 30 miles. And she should have been at 135. And then another 30 miles puts her right where Kevin is. But now he's too exhausted. Put too much energy at the beginning of the race. And Nina saved it. So, another 30 miles, bam, we can see that she's now 5 miles ahead. So after the next hour, she should be 10 miles ahead because it's every 5 miles every 1 hour. So now she's at 2:25. Another hour, 2:55. Another hour, 2:85. Another hour, 3:15. And another hour, 3:45. So now she's very, very, very far ahead of Kevin.
She's only 30 miles. Kevin could come
She
back.
is going super fast. It'd be a little different. All right. Well, it wants other methods. It wants us to write an equation, use logic and reasoning. We could use guess and check. We could revise, find a pattern, and work backwards. You could go to the race, but it would be hard to follow them unless you're in a car or a motorcycle.
We could get a motorcycle.
But we couldn't all fit on it.
Motorcycle game.
No, I have a dirt bike.
Do they have motorcycles that are like a bus, really long? Well, the easiest way that I'm thinking right now, and this one that we've already used, is write an equation. So, let's look at these. For Kevin, we have the equation y equals, he's starting at 90 miles, and then in addition to this, he's adding 25, that's not a good two, 25 miles every 1 hour. So right here, y is your distance, which was represented in the graph, and x is the number of hours. Oh, that's I got that pretty good. Okay. Well, that's Kevin's equation. And then we had Nina's equation, which would be her distance, is she starts at 75 miles and then adds 30 miles every 1 hour. So to solve this one, here's what I got. I got y equals 90 plus 25x, and y, the distance, equals 75 plus 30x. Now the question at the beginning here was, when are they tied, right? Or when will Nina catch Kevin? So the distances would be equivalent, right? Meaning the y's are the same. What this means is that I want the two to be equivalent. I'll do it like this. So I need Kevin, who's at 90 plus 25x. That's his distance. I need his distance to be equal to Nina's, which is 75 plus 30x. Well, this should look familiar from the last lesson. This is just an equation that we need to solve. So, now you guys liked them. It was great. So I would subtract 25x from both sides. This strategy, hopefully you guys learned in 7th grade as well. 90 equals 75 plus 5x. And then right account, I would subtract 75 from both sides. Minus 75. And I get 15 equals the 5x, because this is zeroed out. That was a 0. Very good. Just divided by 5 on both sides. And we see that x, that's the time in hours, is 3. So 3 hours. After 3 hours, Nina should have caught Kevin. Or their distances are the same. But let's look again at the graph and the table. Well, we can see on the graph at 3 hours, right account, that the two have, Nina's caught Kevin. And then also in the table it shows at 3 hours, their distances are equivalent at 165 miles. Therefore, at 3 hours, Nina will catch Kevin. If the bike race is 150 miles long, who would win? Why?
Because Nina catches Kevin at 165 miles, and so if they don't get to 165, then Kevin's still going to be in the lead.
That is correct.
The only thing you don't know is that there's 5 more miles to go, and that as soon as you get off the graph, Nina stops because her bike tire pops for a whole day.
We're going to slash your tires.
We don't. And Kevin wins.
All right.
Now problem, not your problem, Peter.
Anyways, that is correct. Kevin would win because he's still ahead. How many miles is it going to take for Nina to catch Kevin?
15. Yes?
Time. Well, like.
How many miles was it?
165.
165.
They're asking like from 15.
Oh no, yeah, sorry. So now if it was 15 miles more, they would have tied and things would have been great. Everyone could have worn a yellow jacket. All right, now suppose the following. All right, now suppose the following. 90 miles into the race, Kevin is still in first place, and Nina is still in second place, 15 miles behind Kevin. But now Kevin and Nina both finish out the race at a constant speed of 30 miles per hour. When will Nina catch Kevin?
Never!
That's Kevin catching me.
Who would win?
Kevin!
Or when will Nina catch Kevin?
Never!
Why will Nina never catch Kevin?
Because they're open
No, the real answer is we should.
Very good. Excellent. Audrey nailed it. It's because the parallel line thing. Now they're going at a constant rate, but now Kevin is 15 miles always. Always ahead of Nina. What if the race was 150 miles long? Who would win then? Well, still Kevin, because now he's at a constant rate. But he wins by more now this time. The graph below shows the amount of money Alexia and Brent have in savings. Write an equation to represent the amount that each person has in savings after X weeks. Okay, well, there's a couple things on this. We got two lines. Brett's line. Oh, by the way, what?
It's Brent.
Why?
Pretzels.
Yeah, whatever, sorry. Alexia, is that what it was? Yeah, okay. Alexia, her line is going downwards. What does that mean in terms of her bank account savings? She's losing money, right? Or she's pulling it out of her account. Well, you know, if you spend and you don't save or make any money, then yeah, that makes sense. Or she's spending more than she makes. Well, why is Brent's going up?
Because he's cleaning stalls and getting $100 a month.
Fair enough. Whatever he needs to do.
Because I do that too.
So the question, right account, is Alexia spending money faster than Brett, or is Brett making money faster than Alexia spending
So we
it?
need to find the slopage.
That is
so
true,
that's
yes.
Really cool. So it's like
Who's making more or spending more faster? Which one is it?
Alexia, she's a girl, so.
Yes!
I agree.
Okay.
That's not much.
Well, that's not really the direction we needed
Hey,
to go on
I'm
this one.
not gonna lie, I like to go shopping and spend tons of money, but I'm not like, but not.
All right, as it turns out, Brett, since his line is steeper, he is saving money faster than Alexia is spending hers. Okay, well, what does this mean? Well, to write the equation, there's just two things we need, right? We got y equals mx plus b. M is the sloppage, b is the y-intercept. So we could start these off right, and y equals x, and I'll just save some space for the m. We can't find the y-intercept for both of these. Brett's, his is at 0, 0. So his would be plus 0, not that we need to write that in. And Alexia's, hers appears to be at 0, 45, so that'd be plus 45 right here. Next, we just need to find the sloppages of both. So Brett, it looks like after 1 week, he had saved $10. So if I use the stair-step method, I went up 10, and then to the right 1. Giving us a sloppage of, for Brett, up 10, to the right 1 is just 10. Now again, we don't really need that plus 0 right here. But Alexia, hers shows that she, from 45, she went down, she lost $5 in the 1 week. So that would be a sloppage of -5 over 1, which would just be -5. So her equation, y equals -5x plus 45. Kevin and Nina are competing in a bike race. When Kevin is 90 miles into the race, he's in first place. Oh, that's good, it rhymes.
Watch, it's gonna be like a turtle rabbit one.
What?
Yeah.
I don't know what that means, but okay.
Wait, what?
Where the turtle wins the race.
You have it in your head.
No,
Yeah, but then we ate the turtle,
This is a lame bike
no,
race.
rabbit would probably taste better than turtle.
and then when the rabbit crossed, we ate it as well.
Turtle's actually really good.
All right. Whatever the case, you've eaten, dog?
Turtle,
Yeah, we went to Honduras.
Nina's in second place, and she's 15 miles behind old Kev. From this point, Kevin continues the race at a constant rate of 25 miles per hour. Nina continues the race at a constant rate of 30 miles per hour. We need all that information, but it says to draw a picture. Let's draw a picture of Kevin.
Kevin? You can go with Kevin.
I feel like he should have some cool
No,
mustache.
Kevin's fat. And he's bald. That's you.
No, he's not fat enough to be me. Now let's draw a picture of Nina as well.
It looks like a chef at a sushi
Draw the
shop.
Australian dude.
Is that good? All right. I really don't know why they wanted pictures, but whatever. Let's look at the graph. The graph is
Wait,
what
why
we
did
really
they
want
want a
right now.
picture?
Mushroom.
I prefer muffins, but
Could Nina actually be a boy with long hair?
I suppose in some
feel like
cultures,
the
Nina's could be a male name.
sushi
Sure.
guy, I feel like he should have a
Like in Tonga, Daniel is Daniela, which kind of sounds feminine, right?
So maybe his name is actually.
Oh, I wouldn't say that to a Tongan that's named Daniela. Though. Okay. Anyways, I'm gonna do Kevin's graph right now. No, I'm gonna do it.
like Roman. I just watched him.
Kevin.
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 Like Kevin should be Italian.
Well, right now he's just Kev. Let's say he's a Hawaiian dude.
Kevin Nina.
You mean Polynesian?
Hawaiian is Polynesian.
Well, there's also Japanese people.
They're not really Polynesians. They're Asians, right? Or do they I don't know what they identify themselves as. And frankly, I don't care. No, not about, I care about the Japanese people.
Oh, I was
Just,
like, too?
yeah, sure, like,
Someone likes America too much.
well, I do like America a lot, too. All right, anyway, in any
They've
case,
got sushi.
Well, they're American.
that's true. All right, Kevin also is going at 25 miles per hour. Now, on the other hand, we've got old Nina. And she is 15 miles behind Kevin, so where is she at?
75.
75 miles, very good.
Wait, do we put this on other methods?
No, I'm just
Oh,
with the graph right now. And Nina's going 30 miles per hour. This will be extremely important in making the graph. So Kevin starts at 90 miles per hour. That's the only thing we know. We didn't know anything about before this time, so we're going to say it's 0 hours right now. Kevin is at 90 miles. Well, in 1 hour, he's going to go 25 more miles, because it's 25 miles per 1 hour. So to 90, I'm going to add 25, and that would give me
This
115,
would be actually pretty simple.
right?
Wait,
115
what at one?
in 1 hour, right there. All right. So is everyone good with why after 1 hour he's at 115 miles? All right, well, another hour would put him another 25 miles ahead up in here.
like 30.
So that would put us up into 10, 25, right here. Yeah, 140 in 2 hours. Another 25, 165.
Will Nina catch up?
At 100. Come on.
And then another hour, 165, another 25, 190. Right here. All right, so this makes up Kevin's line. Let's go ahead and draw that for old Kevy.
Kevin.
Yeah.
Oh, yeah.
Bam, there's Kevin's line. Now let's draw Nina's line. So we know that Nina was 15 miles behind Kevin at the time. He was 90 miles into it. So that makes him 75 miles right here. Now, Nina's going to go 30 miles every 1 hour. So the next hour, instead of at 75, she should be at 105 right here.
I know where they collide. They collide.
And then from 105, she's going to go up another 30 miles every 1 hour. Bam.
They collide
And then
at
another 30 miles in the next hour. There it is.
165.
And then another 30 miles the next hour puts us at 195 right here.
She passes him up.
So we need to draw the line for old Neener.
Wait.
That sounded like something else.
Whoa.
Alright, well the rest of you guys finish up. Notice, at the beginning of this graph, how far behind was Nina from Kevin? 15 miles. What about after 1 hour?
She was still 15 miles.
No.
She was like 10 under.
And now she's 10 miles. Right? There's 10 between the
five,
purple and the
then
red.
0, and then -5.
And then 5. Why is it that she's moving in 5 miles every 1 hour
Because she's
there?
going
Tanner?
Because she's going 5 miles faster.
That is correct. Every 1 hour. Very good. Very good. Alright, so by this graph, at what, or let me rephrase that. After how much time will Nina catch Kevin?
3 hours.
3 hours.
3 hours. Kevin needs to pick it up.
Now here's the other thing though, is what if this race was only 130 miles? Who would win?
Kevin would win.
Why Kevin?
Because he had a head start and she didn't catch up by then.
No, he didn't have a head start.
And technically,
Because he went faster the first part.
the graph says.
And right here, see this is 130 miles, right? Kevin's line reaches 130 miles before Nina's does. Well, what if the race was 200 miles? Then who would win? Now Nina wins because her line reaches 200 miles before Kevin's.
Ooh.
Next up, it wants us to make a table.
See, I told you he's a-
All right, table, time in hours. Let's start with 0 because our graph did. Then we'll go up 1 hour each time. 3 and 4, and then it stops, so it wants us to redo it down, up, and count. There's time. Here's Kev. And here's Nina. We'll just say Nin for ninja. So Kevin, at 0 hours, how far was he? 90 miles. And then after 1 hour, he's going to add another 25 to these. 90 plus 25, 115. Plus 25, 140. Plus 25, 165. Plus 25, 190-ish. Plus 25, oh, this would be 5 hours, by the way. 5, 6, 7, 8, and 9. Okay. Well, plus 25, that puts us at 215.
Yeah. 250.
Yeah.
And then 240,
Yeah.
265,
Yeah.
290,
Yeah.
315.
Yeah.
Bam, there we go.
You just breathed on my back.
Nin, on the other hand, at 0 miles was at 0 hours was at 75 miles. Plus 30, 105. Plus 30, 135. Plus 30, 165. And there we can see
But even.
at 3 hours, again, it shows that they have come to the same point. And then, but we need to finish this table. So add another 30, 195. Oh, 190. Plus another 30, 125. Plus another, oh, that's 225. 255. 285. 315, yeah, thank you. And then 345.
They don't match up.
They do match up at 3 hours. And again, this shows that the increments are getting closer and closer until they're matched, and then they go farther apart every hour by 5 miles every hour, because Nin is 5 miles per hour faster than old Kev. All right, well, it says to use other methods, particularly writing equation, because that's all we've gone over for the list that it gives us. So let's write some equations. First up, Kevin. And to write these equations, we want to identify what the x and the y be. Well, it kind of told us what that was on the graph. Y is the distance in miles. And x is the time in hours.
So like the y-nex is like the graph y-nex?
Yeah. Yeah, for the equation, it should be the same. So for Kevin, his distance will equal, well, he starts at 90 miles, and then we add 25 miles every hour, so we multiply it by the number of hours.
It's not in order.
Now, yes, I did not write that in order, because right now it's not going to make a difference, and I'll show you why. Next up
But look, you gotta check, guess,
is Nina.
revise, and find a pattern. And then
No, those were suggestions. All right, Nina, her distance was 75 miles, and then we added 30 miles every hour.
Could we use the method get?
Alright. That was a compliment, by the way.
Wait, I'm confused.
That's okay.
What was the end of the sentence?
Yeah, that's good. Okay. Well, what we want right now is to figure out when their distances are equal. So we want the distances to be equal. And that means that we want Kevin's distance, which was y, to equal Nina's distance, which was y. Right account. So y equals y. Yes, we already know the distance, but this is how this works, okay? Because it says other methods. Well, I'm going to replace Kevin's distance with the distance that we found, and that was 90 plus 25x. And this should equal Nina's distance at 75 plus 30x. Well, this should look exactly like some of the equations we did last time. All we need to do now is solve for x. So Radical, I would be subtracting 25x from both sides of the equation. No, that's not right there. There we go, minus 25x. And now I've got 5x Radical. I've got 90 equals 75 plus the 5x. Well, I need to get rid of that 75, so subtract 75 from both sides.
And then that equals 15. No, 25.
Now I got a 15
Oh, I knew it.
equals 5x.
Whoa!
And then you divide it by 5.
And we divide by 5.
So smart.
And we see that x is 3. Now we have to remember, x represents the hours, but what we really want is distance as well. So in 3 hours they will be the same, but how far is that? Well, we just need to plug 3 into one of these two equations. So let's try old Kev. Y equals 90. Oh, that's a plus 25x.
3 times 25.
This is Kevin's distance.
To draw another person.
Alright, well, I'm going to replace Kevin's time in hours with the time that we found, which was 3. And I'm just going to solve for y, which is the distance. So 25 times 3 is 75. So the distance, y, is 90 plus 75, which is 165. So in 3 hours, it's 165 miles. Of course, it would be the same for Nina. But this kind of is the answer that we're really looking for right here. And since it is a word problem, we should label it, which is we have done.
3 what?
3 hours will be better as an arrow. It's an arrow. 3 hours is 165 miles, or 165 miles in 3 hours.
Are you gonna kill Kevin with an arrow?
If the race is 150 miles long, we did this one, who will win? Well, Kevin would win even though he's going slower at this point, because he will still reach 150 miles sooner than Nina will. Now suppose the following: 90 miles into the race, Kevin is still in first place. Nina's second place, 15 miles behind. But now Kevin and Nina both finished out the race at a constant speed of 30 miles per hour. Will Nina catch Kevin? No, because she's behind going at the same rate. She'll just always be 15 miles behind.
It's no solution.
So now if the race is 150 miles long, Kevin will still win. Alright, the graph below shows the amount of money Alexia and Brent have in savings. We need to write the equation for both of them. So, to do these, we need to go back to this y equals mx plus b stuff, because, well, no one really remembers it. Y equals mx plus b. M is the sloppage, and then b is the y-intercept. So all these will set up as y equals mx and something. So I'm just setting these up. I'll fill in the m and the b once I know what they are. And for Alexia, we see that Alexia starts at 0.45. So Alexia's will be plus 45 right here. We just need to figure out the sloppage of Alexia. So I can use that point and I can use this point right here. We can see that it goes down 45 for her sloppage, for Alexia. And then it goes to the right niner. So I got down 45 to the right niner, which simplifies on a calculator to negative 5. So her sloppage is negative 5. Brett, on the other hand, he starts at 0, 0, so that would be plus 0. Of course, we don't have to write that in if we don't want to, but we can find the sloppage now. We can use this point.
Alexa?
He goes up 30 for Brett, up 30, and then to the right, 3. So Brett's slope is 10. So his is 10x plus 0. Is Brett saving money faster, or is Alexia spending money faster?
She's saving.
That depends.
Yes, how do we know he's saving money faster?
That all depends.
Yes.
Like a positive slope.
Okay, more than that. We need to add to that.
It's a bigger positive.
Yeah?
But because Brett has a bigger slope than Alexa.
That's correct.
No, because
Brett's slope is bigger, and on the graph it is steeper as well.
That's what I was gonna say.
Very good. If it is steeper, then it is happening much faster.
Wait, but Alexia doesn't even.
How many weeks will it take for Alexia to run out of monies?
Nine.
9. It shows it right there,
It
9.
says it on the card.
Yeah.